Hey guys, so today we are going to do our first lesson in our chapter 5, normal probability distribution. We're going to look at the first part of lesson 5.1. So normal distribution has to have a continuous random variable. So a continuous random variable is a variable that has an infinite number of possible values that can be represented by an interval on the number line. So here we have this example down here, hours spent studying in a day. So you can have an hour and 1 minute, an hour and 5 minutes, 3 hours and 54 minutes, 7 hours and 23 minutes, 7 hours and 23 minutes and 6 seconds. There's so many variables, there's so many different times. You can have all those little times in between. That's what makes it an infinite number of possible values. That's what makes it a continuous random variable. And those are the kind of variables that you have that will create these normal distributions. So a normal distribution is a continuous probability distribution for a random variable. The graph of a normal distribution is called the normal curve. You can see that on your paper or right above here in the video, this blue shape right here, that's our normal curve. It looks like a bell. It's often referred to as the bell curve. So when working with normal distribution, there's something called the empirical rule that allows us to quantify how much data falls within our normal distribution. So for data with a normal distribution, the standard deviation has the following characteristics. 68% of data falls within one standard deviation. That standard deviation is sigma. 95% of data falls within two standard deviations. And 99.7% of data falls within three standard deviations. That is, you can see that here. We have our mean, our mu here in the middle. And then this is one standard deviation to the right. This is one standard deviation to the left. We get our 68%. This is two standard deviations to the right, two standard deviations to the left. We get 95%. Three standard deviations, so on and so forth, we get 99.7% of data. That still leaves 0.3% of the data that's not covered. So that tells us that on these far corners here, there's 0.15% that is above three standard deviations and 0.15% that is below negative three standard deviations. So we can use that empirical rule to find what percent of data lies within data points. So in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States, aged 20 to 29, was 64.3 inches, with a sample standard deviation of 62 inches. Estimate the percent of women whose height is A, less than 66.92 inches, and B, between 59.06 and 64.3 inches, and then larger than 69.54 inches. So first, let's fill out our normal curve. So right here in the middle, our mean is 64.3. If we go to one standard deviation to the right, we would add that standard deviation, we get 66.92. Add two standard deviations, and we get 69.54. Add three standard deviations, and we get 72.16. Subtract one standard deviation, and we get 61.68. Subtract two standard deviations, we get 59.06. And subtract three standard deviations, we get 56.44. So that's just doing some adding and subtracting with our mean and that standard deviations of 2.62 inches. Now, if we remember from our empirical rule, we're going to have 34% data right here, 34 here, 13.5% here, 13.5 here, 2.35 here, 2.35 here, and this last little bit is 0.15, 0.15. Okay. So A wants to know less than 66.92. Okay, so we want to look at everything that is less than 66.92, that's right here. So we would add together all of these percentages. And if we add all those up, we should get 84%. Our next one, B, it wants us to find between 59.06 and 64.3. So that wants us to look between right here and go all the way to our middle. So we're just adding up those two pieces there. And that should come up to 47.5%. And then the last one wants to know larger than 69.54%. So we're looking at everything to the right of 69.54. That's just those two pieces right there. Those are going to add together and give us 2.5%. Okay, now that we have gone over example 6, I want you guys to go ahead and look at the bottom of the page there and try example 7 on your own. One thing, A should be 0.329, and B, that first one, should be 0.193 instead of 92. So whenever you're doing those problems, keep that in mind. So go ahead and do exactly what we did for example 6 for example 7. Pause the video and come back for the answer.